Hello and welcome. In this set of videos, we will talk about floating point operations, but we're going to build up this discussion from the ground up a little bit. So we'll talk a little bit about converting fractions from decimal to binary and converting fractions from binary to decimal. We'll talk about how these numbers, when they're in fractions, like how do fraction numbers get stored in memory, and when basically when the CPU looks at the memory and knows like this is a fraction point or it's a non-integer value, how does this value get represented in the program? And then we'll talk about how, we'll talk about two ways. We'll talk about fixed point representation, how these non-integer values get represented in binary, and we'll talk about floating point. So there's fixed point representation and there is floating point representation. And then once we're done with that, we'll talk a little bit about how to do the operations in floating points, or they call floating point operations. I'm sure you've heard of this before. You've heard of floating point operations or flops, and then sometimes they measure like how fast the CPU is and how many flops or gigaflops or megaflops per floating point operations per second the CPU can do. So it's a pretty good thing to get to know and understand where this is coming from. So let's go ahead and get started. We'll do a quick example to illustrate the point of how floating points work. So let me start here. So if I have a value, let's say I have a binary value. Actually, let's start with a decimal value. So let's say I have the value of 5.5. And historically, many people know how, I'm assuming you know how to do binary value conversions. If you want to convert this to binary, you'll get 101 in binary. Now, how do you convert this part to binary? That is the question we're trying to answer. Well, it's actually rather pretty straightforward. You can ask yourself, for example, what value in terms of, if I need to use the number 2 to represent 0.5, what is that value? Well, it's actually 0.5 is actually equal to 1 over 2. And I can write 1 over 2 as 2 to the power of negative 1. So this value actually is 2, one digit to the right of the decimal. So it's actually 0.1 in binary. So this number is 101.1. So now this gives me a further insight into how to convert numbers back and forth. Well, at least from binary to decimal. So if I have the value, so basically I can write this here all the way. I have a radix point here, and I have digits to the right of the radix point. So this is to the power of 0, 1, 2, 4, and so on. And then this becomes to the negative 1, negative 2, negative 3, negative 4, and so on. So if I have a binary value and I want to convert it into decimal, I can do that rather pretty straightforward. So if I have the value, let's say 1101.01, and I need to know how much is this value, this is base 2, and I need to convert this into base 10. What is that value? Well, this becomes 1 times 2 to the power of 0 plus 0 times 2 to the power of 1 plus 1 times 2 squared plus 1 times 2 cubed, 0 times 2 to the negative 1 plus 1 times 2 to the negative 2. And in this case, I can going to just add these values together. So 1 times 2 to the negative 1 times 2 to the power of 0 . So 1 times 2 to the power of 0, that's 1, plus 0 times 2 to the power of 1, that's a 0, plus 4 times 1, that's a 4, plus 1 times 8, that's an 8. 0.0 plus 1 over 4. So this value is then 13, and then 0 plus 0.0, so a quarter, which is 0.25. So like that. So that is the decimal value for that binary number. So essentially, this becomes 13.25 in base 10. And that's it. That's how you convert numbers from base 10 to decimal, especially if you have fractions. There's another way which I will show you to convert any number. So those ones are pretty straightforward. So it's a systematic way to convert the numbers from binary into base 10. You can actually use this method to convert fractions from any base to base 10. I'm not going to get too deep into it, but since we're already talking about this, I might as well just throw this piece of information out there. So assuming that you're working with, let's say, hex values. So let's say you have 4f2.9a0. How much is this in base 10? Well, you do the same thing. This will be 2 times 16. Oh, why did it go to 0? Okay. So this is 2 times 16 to the power of 0 plus f is 15 times 16 to the power of 1 plus 4 times 16 squared point. This is 9. Bring it down. Times 16 to the negative 1 plus a is 10 times 16 to the negative 2. You carry out the math equivalent of these values and you get your number in base 10. So it's pretty straightforward. Maybe we can pause here, and then on the next video I will show you how to convert numbers from decimal to binary, or non-integer numbers from decimal to binary. Thank you for watching.